Begin implementing fqueue class pragma once class fqueue is the name, then semicolon at the end. Private members we are going to create an array dynamically, so let's have integer point p array. Remember that we are using int type only as data. We are going to extend it to any data later using a template mechanism. Then public member and constructor like that. So let's first take care of a constructor. Include fqueue.h and fqueue constructor. So what we want to do is we want to create an integer array of size of the array. So when you define an fqueue object, we need to specify the size of the array. So integer size is provided. Then let's remember the size into size member variable. So we need to have a size. That is a size of the capacity of the array is there. Then as we learned from the circular array implementation, so we need the index of a front and then index of a back is needed. Then let's have another member variable called count. There's number of data in the queue. We didn't have that in a stack. We don't need it as a basic, the very minimal implementation though, but count is called the queue length in queuing theory. So we are going to implement a function called the length, that is a number of data in the queue. So for that purpose, let's have a count variable. Also then using the count variable, you can easily tell whether the current queue is empty or full. So we need to initialize those variable as well. So here size is s. So let me give this on next line, since we are going to initialize a few more. And then I front and then I back should be initialized. Here, what would be the good value for I back and I front initialization? For finding that out, let's consider how we are going to use the circular array. So let me erase those parts again, and then let me find it out. Those ones. So here we have a circular array. Let's have some small size 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4, 5, 6, 7. So it's a size of the array is 8. And this currently count is 0, so this is empty. Then if I do a first push with the data 5, then data 5 will be stored here. And that moment, I front of the queue is at index 0. And also back of the queue is 0 as well. And then what you do in push operation is the back, I back is the index of the last data. So we are going to the first step of push is we are going to increment I back and then store at index I back. That is a push operation we are going to do. So when you add a push, the very first data, front as well as back is at index 0. So which means when the queue is empty, I back should be one less of the current one. Current one is 0. Then if I back is a -1, then when you add the very first data, I back becomes a 0, like and then I front as we add the very first data, I front becomes a 0 as well. So we can use those two information, and then we can initialize I back is 0, -1, and I front is 0. Then as you do first push, I back is incremented and then store data at I back, that is at index 0. That makes sense, so that we can have those as a first initial value. And then we have a counter variable which should be 0 at the very beginning. So that's the constructor part. And then a destructor is when you do dynamic memory allocation at destructor, you need to free the memory. So we allocate the memory dynamically here. So at destructor, we need to free the memory. That's what destructor should do.